Hello and welcome to Chapter 2. We're going to get started. Chapter 2 is we're going to be talking about different types of studies. So we're going to be talking about surveys and then comparative studies. So types of studies. A study is a description of population characteristics, i.e. a study of the prevalence of hypertension in a population. Comparative studies determine the relationship between variables. An example would be a study to address whether weight gain causes hypertension. So here we have a basic outline of what studies can look like. So we want to do a study. So there's different types of study. We can do a survey, or we can do comparative studies. And under comparative studies, we have experimental or non-experimental, which we like to call observational study designs. So first up, we have surveys. So the goal of a survey is to describe population characteristics. We have a study as a subset or a sample of a population, right? Because we can't really survey everybody. So we're going to take a sample of the population that we want to learn about. And then we use this sample to make inferences about the population, right? We used this word before in Chapter 1. Inferences when we're taking a small set or a sample size, we're running and collecting information or data, and then from that we're going to make inferences about the population, right? So we're going to take a small sample size and infer it to the population. Sometimes we can do this really great, and other times, there are things that get in the way. Main thing we want to do here is, we can't survey everybody, but we can survey a lot of people and get a lot of information, make inferences about a population. Great things about surveys. Sampling is it saves time, it saves money, and allows resources to be devoted to a greater scope and accuracy. A lot of times we might start with a survey to see if we might have a great idea on something, right? Maybe it's a weight loss program, maybe it's a weight gain program, or maybe it's on exercise, or maybe it's to decrease cholesterol. Whatever your idea might be, sometimes a lot of people might start off with a survey to collect a bunch of information, and if their hypothesis is still correct after collecting surveys, then they might go deeper down and do a more I don't want to say invasive, but they might get more data. They might collect a lot more information to see whether or not what they're actually trying to do works. Surveys are kind of on the broad scale here to just collect a lot of information relatively quickly. Once we start getting into actual study designs, these take sometimes a lot of time, take a lot of money, and when you have grants or someone funding this particular project, they want most of the time the results very quickly. They don't want to take a lot of time. Surveys kind of help get us down the right path and get us going to where we need to go, and can collect a lot of information relatively quickly and make sure what we're looking at is actually something worthwhile. So here we have an example of a study of surveys, and this is called the YRBS, or the Youth Risk Behavior Surveillance. If you're not familiar with this is a huge study that goes on, and it measures the health behaviors in youth and young adults in the U.S. It has 6 categories of health risk behaviors. They are behaviors that contribute to unintentional injury and violence, tobacco use, alcohol and drug use, sexual behaviors, unhealthy dietary behaviors, and physical activity levels and body weight. So the survey is done every year, and it's given out a lot of school districts participate in it from all over the country, and they collect this information. This is how we learn about our youth and what the trends are going towards. So here we have in 2003 from the YRBS, they had a questionnaire or survey that was done, and 158 schools took part in this. And one thing to always take in consideration, look at the schools that they did. They had public and private schools, right? If they only did public schools in this survey, it might be a completely different demographic in private schools. But by combining them and having them balance out, we can then infer based on collecting data from both areas about the youth that go to the school districts. You can also see that they had 15,240 questionnaires completed. So that's quite a bit, but there are a lot more students in this, but we can't pull everything. So they're pulling a bunch of different students from different parts of the country. It's not just all on the East Coast or on the West Coast or South or North. It's from all over the country, public and private schools. Of those students who completed the questionnaire, this is the sample that they got. The information is then used to infer the characteristics of several million public and private school students in the United States from that period, right? So this is showing an example of how we collect information from schools, and then from that information, we can infer based on, the average height and weight of youth and our young adolescents, growing up, if there is weight gain. This is where we can say that, kids are, their BMI is growing. We could say that they are less active. They are engaging in risky, sexual activity, or they engaging in, drug use at an earlier age. This is how we collect and disseminate this information. Moving on, we have now simple random sampling. So we have probability samples, which entail chance in the selection of individuals. This allows for generalization of populations, right? If we purposely selected certain school districts, we might know certain characteristics, and that can cause bias. We have to have a random sample. Only by being truly random can we actually decrease bias here and allow for generalization to happen. If we don't have random, we can't make generalizations. The most fundamental type of probability that you'll see is called a simple random sample, abbreviated SRS. And SRS is the size of n selected so that all possible combinations of n individuals from the population are equally likely to compromise the sample. SRS demonstrates sampling independence. So here we have SRS, the size of n. Anytime you see n, it's going to infer how many people are in the study. N size, you'll see like n equals 32 might be the size of how many students in a classroom. 32 students in a classroom, n equals 2, the size of the individuals that are likely to compromise the sample set. So here we have sampling, random sampling method. So we have a number of population members, 1, 2 to the nth. We want to pick an arbitrary spot on the random digit table. So here in our book, if you go to Table A, which is found on page 539, you'll see Table A, and it's a random digit, or Appendix A. And it's the table of 2,000 random digits here, and this is one way that we can randomly pick people or pick school districts. Depends on how you want to label it, but this is how we can randomly assign it without having any kind of bias in there. So when you go to Table A, you'll see that there's lines, and then there's 5 sets of numbers, and then a tab, and then another 5 set numbers, and all that's done all the way through the lines. So you can go down the rows and columns of the table, select n, the appropriate tuplets of digits, and you can discard the inappropriate ones. Alternatively, you can use the random number generator to generate n number tuplets. Tuplets is just a fancy way of having a finite order of a list, or a finite ordering of pairs. So you could have, and by pairs I don't mean 2, but you can have triplets or more, depending on how many people you're looking for. It's just the finite ordered list in which you're looking for in it. So here we have an example to go through. So you have a high school population that has 600 students. And you want to choose 3 students at random from this population. All right, to select an SRS of n equal 3. So our simple random sample is going to be 3, but you have 600 students to pick from. So you get a roster of the school, assign each student a unique identifier 1 through 600. Now, the key part here is we have 600, right? And we also have 1. We have to, how many ever significant figures out the largest number is how many digits is going to create our tuplet here. So here we're going to be going at least 3 significant figures out. So 1 is actually going to be 3 significant figures out, which is going to be 0, 0, 1. Right? And then the next one would be 0, 0, 2, and then 0, 0, 3. And that would be those individual students on this list. And we want to pick 3 of these students at random of the 600. So this is going to go all the way to, this would be 599, 600. And that would include all the individuals on that list, and we want to pick 3 of them randomly. So part 2 then would be go to Table A, and then for our purposes, we're going to select line 15. And if you go to line 15 on page 539, you'll see that it starts off with 76931, and then 95289, then 55 809, so on and so forth. So here we start here, and this is our digits. Now what we're going to do is we're going to go out 3 digits, or 3 significant figures, stop, and if those 3 digits fall in between 001 and 600, then that will be the student we pick. And once we get 3 students from this sample, this population, we've found our 3 random students. So just to show you what this looks like, so we got 3 significant figures, so it's 769. That does not fall between 1 and 600. So these 3 numbers would be out. So then we're going to go to the next 3. So 3, 1, 9. So 319. Kind of bracket that off. 319 does fall between 1 and 600. So we're going to write that down. 319. And then our next 3 is 528. Cross, kind of slant that off there. 528 does also fall between 1 and 600. And then our next 3 would be 955. Well, 900 isn't in our between 1 and 600. Our next 3 would be 809. That doesn't fall between 1 and 600. So cross those off. Our next one here is 193. 193 does fall between 1 and 600. 193. And then these are our 3 students. So then we go to the list, we find those students that match up with those numbers, and those are now the students that we have randomly picked from this population to be randomly selected for whatever we are looking for here. So next slide here just goes over basically what I just did there, just more in a text format. And as you see, we end up with the same numbers: 319, 528, and 193. Those are the numbers. Those are the individuals that we picked for this sample here. All right, so a couple cautions when we're sampling. We can have what's called undercoverage, so groups in the source population are left out or underrepresented in the population list. Use to select a sample example of this, right? If we only included public schools in the YRBS, we'd be leaving out private schools, right? And sometimes there are public charter schools or public private schools, and we can maybe be leaving those individuals out if we just purely look at the definition of like a public school. You know, another sampling that maybe not, that isn't incurred in there is homeschooling, right? We're not getting individuals who are homeschooled, so we're leaving those people out of the survey, so those individuals are not covered, so there's under coverage in that population. Volunteer bias occurs when self-selected participants are atypically the source of population. So, right, if you're randomly walking through the mall and you get stopped to do a survey, I do not have the same probability of being selected if I'm not at that mall, right? And then if you don't want to engage in that survey, you're not going to do the survey versus someone who is. So people who are more likely to volunteer to be part of a survey are be the individuals that are likely to, the results are actually reflecting, right? If people don't want to take a survey, you're not getting those individuals who don't want to take a survey their responses. So there's volunteer bias that can happen. Non-response bias, probably one of the biggest ones, occurs when a large percent of individuals just refuse to participate or cannot be contacted, right? You get called up on your phone, please fill out the survey, or you buy something online, or you do a service and then there's an email following it, please take our survey and tell us how we did. And many times people probably don't fill it out, right? That's non-response bias. There's other types of probability sampling. You have stratified random sampling, cluster sampling, and multi-stage sampling. You can learn about these online. The book slowly talks very little about these, but we're not going to go through these in this course at this particular time. All right, I'm going to stop this video here and then pick up the next video on comparative studies. Have a great day.